Although it's been going on for centuries, the search for extrasolar planets has only really begun to take shape in the last few decades. Only in the 1990s was the first extrasolar planet detected with certainty. Since then, more than 4,000 exoplanets have been found, the majority of them in the years between 2009 and 2018 by the Kepler Space Telescope. Kepler used a technique called the transit method to detect planets outside our solar system. The telescope would focus on specific areas of the sky and measure the brightness of stars. If there were any dips in the amount of light reaching the telescope, it would suggest that an object, possibly a planet, was passing in front of the star. However, this alone wasn't enough to confirm the existence of a planet, as there could be other reasons for a temporary reduction in a star's brightness. To be sure, Kepler needed to observe at least 3 instances of dimming at regular intervals before it could confirm the presence of a planet. Kepler was designed to constantly observe a large region of space, not just a single star. This was crucial because transit events can be brief, and any interruption in observation could result in missing them. The sheer number of planets that Kepler discovered is a testament to its efficient design and successful execution. The mission lasted for 9 years before the telescope's control system became depleted and it was retired, surpassing its planned mission duration by over 5 years. The vast majority of the planets discovered by Kepler are not well known to the general public. While the general public was not made aware of the vast majority of planets discovered by Kepler, the one exception is Kepler-22b. This planet was the first Earth-like planet found in a habitable zone, and the first confirmed planet outside of our solar system that had the potential for supporting life, if we could ever reach it. In February of 2011, NASA announced the discovery of Kepler-22b as one of 54 potentially habitable planets found by the Kepler Space Telescope. When Kepler-22b was first discovered, it was often portrayed in the media as being a second Earth, orbiting a distant star. This statement is only true in its most basic sense when compared to the diverse array of planets that exist in the galaxy. In reality, even though it has similarities with Earth, if we were to visit Kepler-22b, it would still appear vastly different and alien to us. It orbits a star that is similar to our own Sun, but it's a little smaller, older, and less bright. This means that it doesn't produce as much heat as we're used to. However, Kepler-22b orbits its star closer than Earth orbits the Sun, which compensates for the difference in heat. It's crucial to understand that the distance a planet is from a star is not the sole determinant of its ability to support life. The composition and atmosphere of a planet also play a significant role in determining its average temperature. For example, if the distance from the Sun was the only consideration, we would expect Mercury to be the warmest planet in our solar system. But that's not the case. Venus, which is further from the Sun, has a much hotter average temperature than Mercury because of its thick, oppressive atmosphere. Kepler was not able to determine the composition of a planet's atmosphere, so we're only able to make educated guesses about the climate on Kepler-22b. It's believed that the climate on this planet is similar to a mild spring day on Earth, around 72 degrees Fahrenheit. Additionally, some models suggest that the planet has a tilted axis, with each pole facing the Sun for half of its 290-day orbit. This could contribute to an even milder climate, but there's no confirmed evidence of this. Assuming the atmosphere is similar to Earth, we can imagine a planet with breathable air and mild weather. It may sound like a paradise, but it's important to remember that there are other factors to consider when evaluating the habitability of a planet, such as its size and structure. Kepler-22b has been referred to as being similar in size to Earth, which is only partly true. In reality, it is 2.4 times the diameter of Earth. However, this does not necessarily mean it has 2.4 times the mass. Without knowledge of the planet's composition, it's difficult to calculate its mass. It could be mostly gaseous, in which case it would not be very massive, but also not a suitable place for life to exist. On the other hand, if it is made up of similar materials to Earth, such as rock, iron, ice, and water, its mass could be around 10 to 15 times that of Earth. Additionally, the unknown gravitational forces on the planet's surface could be more than double that of Earth's. This would make everyday activities and movement on the planet more challenging. The high gravity would also likely limit the size of animals that could exist on the planet's surface. It is also suggested that the planet may be covered by a global ocean, similar to Neptune. This would be good news for aquatic life, but not for any potential human settlers. Kepler-452b. Over 5,000 exoplanets have been found so far, and approximately 100 of them may be suitable for life, since they are in a star's habitable zone. With the technologies we have now and the help of artificial intelligence, we can speculate on how life might be. The exoplanet Kepler-452b might just be the perfect choice for an alternative home. Located 1,400 light-years away in the constellation of Cygnus, Kepler-452b orbits a star that is actually brighter than our Sun and falls within the habitable zone. A year on this planet lasts 385 Earth days, a similar duration as on Earth. The planet's surface temperature might be similar to that of Earth, and the presence of liquid water suggests that life may have the potential to exist on this planet. If not for the fact that it is 60% larger than Earth, implying that its gravity is twice as strong, the conditions on Kepler-452b could be quite similar to those on Earth. However, life forms may be able to adapt to such gravity. On this planet, small bushes and trees might thrive, scattering their seeds into the air due to the intense gravity. Additionally, the air density on this planet is 5.5 times greater than on Earth, which could allow seeds to float above the ground until they're carried away and eaten by flying herbivores. Due to the planet's intense gravity, all life on Kepler-452b would likely have adapted to living above the ground in the air. As per our artificial intelligence scenario, the first life forms that may be observed on this planet are large flying creatures, possibly resembling stingrays, with long tails and powerful wings. They would never land as they continuously fly through upward air currents. These creatures are likely to be herbivores and would feed by flying through clouds of floating seeds and scooping them up with their large round mouths, similar to how humpback whales feed on Earth. Unlike whales, these large flying creatures will have natural predators. At first glance, it may seem unlikely that a large stingray creature could be threatened by a balloon-sized bug, but these predator bugs hunt in packs. They're equipped with carbon-releasing bacteria that allow them to hover above the ground while searching for food. They quickly release carbon from the bubble and launch a lightning-fast attack when they locate their prey. Similarly, on Earth, falcons hunt by diving straight down from a height and capturing their prey at speeds of up to 100 meters per second. On planet Kepler-452b, the force of gravity is 20.5 times stronger than on Earth. This implies that our imaginary predatory beetles may move faster than a falcon. They use their long paws with hooks at the tips to hold on to their prey once captured. A large flying stingray-like creature could be brought down by a group of these beetles. Once on the ground, the prey can't escape and the beetles will begin to slowly consume it. The beetles will then fill their bubbles with carbon dioxide and rise back into the air in search of a new target. The giant air rays on planet Kepler-452b are not only threatened by the hunter beetles, but lead a life of danger from before birth. After mating, the females of the species descend to a hill to lay their eggs, but due to their massive weight and the planet's strong gravity, they're unable to take off again and die near where they laid the eggs. For the chicks that hatch, a perilous journey off the edge of a cliff awaits them, where they must jump to catch the air currents and take off. The journey is fraught with danger though, as they may be overtaken by scavengers along the way. Our imaginary scavengers are shapeless invertebrates that have adapted to the high gravitational force. They capture the chicks by falling on top of them and wrapping themselves around the victim to digest it. Unfortunately, out of the hundreds of chicks that hatch, only a few dozen make it to the cliff's edge. Life on Kepler-452b is truly a fight for survival. When it comes to human habitability, the biggest obstacle on Kepler-452b would be the high gravitational force, which is twice that of Earth. Our bodies would be under constant stress, resulting in high blood pressure and an increased risk of heart attacks and strokes. Living on the surface of the planet would be nearly impossible, but it may be possible for humans to survive in the atmosphere. To inhabit this planet, we would have to construct floating cities, a tremendous and costly feat in itself. So how about it? Are you ready to move? Do you think you'd be able to build a life for yourself on Kepler-452b? Although we currently have limited knowledge about Kepler-22b and the other discovered exoplanets, the ongoing research in exoplanet study is making it clear that the universe is filled with a vast number of planets, many of which could potentially support life. The future of space exploration is promising and exciting, and we should strive to gain knowledge and understanding of the other worlds out there.